Hey guys, welcome to Tommo Tinkers. In this episode we're carrying on with the Bloodfall Catacombs and we're going to add a couple more rooms and objects to the game in this video, and we're going to see what new engine features we have to implement to make the interactions that we might want to create work. The first thing I'm going to do is I'm just going to get rid of this unused namespace here. And okay, so let's start with creating some more rooms. What should we call this? We're gonna have we have our cell that we start in, which leads onto the corridor, and we'll have another door across the way, I guess, and it leads to another cell. What should we call it? Let's call it the opposite cell for now. This is not being very imaginative, but then again, this is some kind of prison. It's likely all the cells would be the same. Okay, so let's create another object or another thing, and we'll call this the door. This is the object that will be in the corridor. Large wooden door with a keyhole. And is it takeable? No. We're not going to allow the player to carry around doors in this game. There's the namespace for link at the top there. We're not using it in this file. And now we will add the door to the other cell. And there we go. Now we're not going to add an exit for the door. I'm sorry, we're not going to add an exit for the other cell. The door is going to behave as the exit and handle that for us when you use it. So it sounds like we need a move command. Let's set this up here. Add a command handler, command.use. Create the necessary methods and enumeration, and in the command handler we've got the use, and in the command parser we have to set up the string that you have to type to use it. Now we have the command handler set up. So we have our use command. Of course it doesn't do anything. I'm going to put the use command in its own file. I think it's a good idea to start breaking these up a bit. I'll just take this from here, close this and put it here. Rename the things, game state, and the arguments. Now the arguments should be another object. So what do you want to use? So let's have a look how we've done this in some of the other handlers. We should kind of the object name is doing the same thing here, so we want to get the object name from the argument. We could make a method for this, although it's not really a command handler. I guess it would be in utils. Or would it be? Yeah, okay, so basically this is the stuff that we're going to end up writing in the new handler anyway. So we'll make it into a method. We'll make it as a extension method on the game state. Make a folder for this. Now for an extension, to create extension methods, they have to be in a static class. We want to get a thing, public static thing. Get thing from string. Or we could get thing by string. Okay. Let's just fix this. This is in a different class now. This is in, where did we put it? The use command handler. Okay. And this needs to return a thing, so let's steal from here. See, the only thing we're missing now is the object to take, which we will resolve using the new method we're creating. Be more specific by name. We don't need this. This should really be called thing name. We should have a little bit more consistency. Okay, so we need to decide here how we want to. This should have a return, which it's not going to allow us to do. We can return null. This is not my favourite way of dealing with errors. Now we still got these write lines proliferating our code, and this is not good. We'll deal with this very soon. We have this dependency on system.console in all our files, and the more it proliferates, the harder it is to actually make it output to somewhere else. So we'll create a wrapper around this shortly. No, I've not made this an extension method. This also requires the game state. Now to make an extension method, you have to type this to make it become a extension method. I'm going to bring back Lincoln, and we're going to call this the name. Okay. The thing, because it's is actually what it is, and then if all is good, we'll return the thing. The issue we have here is there are two different kinds of things that could go wrong, because this method is still relating to taking things. We'll get rid of this output here, and we'll deal with it First default. Okay, so yeah, that works fine. We're still going to return null if we can't find. If this fails, then the thing will just become null and it will behave as before. So now we can redefine the object take method here, where that name is actually relevant, and we can call our extension method. And get thing by name until the has managed to find it, and we'll pass our name in arguments 0 or arguments dot first or default, because it's an IUsable. You can't do indexing on it. Okay, so before we go any further, let's check that the take command still works. Let's see if our refactoring hasn't changed the way the game works. Can we still take the key? We took the key. But what happens if we are naughty? I think we'll get a crash. And that's correct. We can't do this because we can't check if it's takeable, because the asjod object, which I have not defined yet and probably never will, doesn't exist, so our new extension method returns null. So we have to handle this error. Right, line. There is no here. Of course, we'll use string interpolation for that in a minute. We'll just alias out this variable. I'm going to think of a better name than input in a minute. We can use Riders to put in the string interpolation for us. No problem. What would we call this? The name of thing input. And of course we want to place a return here. And that should solve that problem. And of course there isn't one because we didn't create one. But we can still take the key. We can still drop the key. Now, does the drop command... You see, the drop command operates the same way. So we'll just... we'll get rid of this. We don't need that. It does work slightly differently because it uses a different collection of things. Let me see, get thing by name. What does this actually do? Yeah, see, it's looking in the room for where to look for things to get, but actually, so we'll change this. I have a better idea. We'll of get thing by name, and instead of having it as an extension method on the game state, we'll have it as an extension method on an IUsable of thing. So we can specify which container of things we want to look in. So now we can do, in the take command, we can call it on the things.get thing by name and its name of thing input. But in this one, we will call it on the inventory. And then we can get rid of this. So now we should be able to drop things as well. We can still take the key, inventory, which shows we have the key, drop key. And now the key's back in the room, and in our inventory we don't have anything. So that's all good. So now we can use this in our use command handler. Object to use equals arguments.first.default. And it's thing, not objects. I need to get out of that habit. Thing to use input. Thing to use. Now, we have a problem here. We want to combine we want to be able to use things in the inventory as well as things that are in the room. So if we go to the game state, we have done this before. We used a concat somewhere, I believe, in one of the handlers. I think it was in the look at command. Yeah, here. This isn't a game state extension anymore. We'll make a miscellaneous folder for extensions. And we'll put game state extensions in here. So we'll make another extension method. We want an IUsable of things. I'm going to give this a verbose name, get all things users can interact with, and we'll just pass in the game state. Oh, this has to be static because it's an extension method. And then in the handlers, get rid of this. We'll put this here, and we'll bring in link. So now we can just do game state that get all things users can interact with. At the moment, this just does what it was doing before. It just combines the inventory things with the things that are in the room. call this variable all the things, but with good casing, because that's important. And now we'll get the one from the input. Okay, so now we know what object they're trying to use. Okay, so how do we, what's the best way to go about this? We want to be able to code the usability into the thing itself, but not everything's going to be usable. So we'll make the concept of usables and this should be an interface. Not a class. So what this allows us to do, instead of creating a door as a new thing, we can create it as we can create a new type of thing, and this will derive from thing, but it will also be IUsable, which forces us to implement the constructor of the thing and the use method. And for now we'll just put in I've never used the name of operator before, it's a new feature. We'll just use static system console to bring the console in another piece of technical debt. Okay, so now we can create, instead of creating a thing here, we can create a door. We'll bring in the namespace for that. So in the use command handler, we want to specify things that can be used, things that can be used, and that'll be, we'll use T for thing, so we'll use the where, and we will, where T is an IUsable. So this will only get us things that we can safely call the use method on. And we can also put a cast in here as well, cast to IUsable. No, we can't do it that way, because now this is an IUsable and the thing, the method is called on an IEnumerable of things to use. So our interface structure's a little bit wonky here, but our ordering's wrong anyway. What we should do is get the thing the user typed, and then we'll check if that is an IUsable. But first we can check if the thing actually exists. If the thing to use is null. How did we handle this in the other? I can't see a thing. Anyway, we can break this out because this is when we're about to duplicate this. So this is a candidate. This is a code smell that we should break this particular piece of functionality out. The what to do when the user types a thing that cannot be found. Instead of repeating the code everywhere, we'll refactor it and put it in one place. There's a lot of small refactorings that need to happen, ideally, and we'll probably spend a video or two soon just taking care of those and cleaning the code up as we go, so it doesn't over time become out of control and very difficult to manage. Of course, I've typed the wrong thing. We actually want what the user typed. Thing to use is not if not, thing to use is IUsable. Right line. Cannot use this. We need to put returns in here as well. Okay, so I guess now that we know it is an IUsable, I think we can do it like this actually. And if this fails, it returns null. I think that's how it works. I can't 100% remember. Oh, we have pattern matching in this new version of C#. This is a feature I've not used yet, but I've used it a bit in F#, so we can simultaneously define the variable within the pattern. Does the usable still exist in this scope? And then we'll call use and we'll skip the first argument, which is the object. Okay, so yeah, so the usable variable defined here in the if statement exists past the scope. So I'm good with that. It's a nice little feature. Saves a couple of lines of code. It's a little bit more succinct. Okay. So let's test what we've got. Use key. Cannot use this. We can take it though. Move north. Look. But we cannot see our door. Why not? Interesting. Oh, we added it to the other cell, not to the corridor. What is it? Set it to the corridor. Let's try again. Go north. Okay, now we have the door. Use door. You use the door. Okay, so what we've managed to accomplish here is the code specific to using the door is defined only in terms of the door. The code that handles the commands doesn't really care what object we're using, it just passes control to whatever the thing is that we are trying to use. So we can implement custom logic here that's only specific to the door. And we shall do that in the next video. Thanks for watching, guys.